Hello students, this is lecture 8 from the unit 1 OEC552 soft computing subject. In this lecture we are going to see the problems on the fuzzy set relation, that is Cartesian product, max min composition and max product composition. First we start with the max min. This is an example problem. We have a two relation R and the S. R contains the relationship between the fuzzy set x1 x2 with the y1 y2. S contains the relationship between the fuzzy set y1 y2 with the z1 z2 z3 fuzzy set. Now we are going to identify the max min composition for this R and S. To choose the max min value for the R and S, specifically x to the z1, we have to compare the x to the y1, then y to the z1, choose the minimum value from these two. Later, x1 to y2, y2 to z1, choose the minimum value from these two. Comparing these two minimum value, which is having maximum value, that we have to assign for a x1 to the z1. Now we'll check. Here x1 to y1, the value will be 0.6. y1 to z1, the value will be 1. So we have to prefer the minimum value from the 0.6, 1. The value will be 0.6. Take this value. x1 to y2 0.3, then y2 to z1 the value is 0.8, minimum value from this two is 0.3, comparing 0.6 with 0.3 the value will become as 0.6. So take the second one, x1 to the z2, so 0.6 with the 0.5, x1 to y2 0.3, y2 to z2 is 0.4, 0.3, 0.4. So minimum value from this two is 0.5, here 0.3. Comparing the 0.5 with 0.3, the maximum value will be 0.5. Take the value for x1 to the z3, comparing 0.6 with 0.3 and x1 to y2 0.3, y2 to z3 0.7. So minimum value from this two 0.3, minimum value from this two 0.3. So maximum value will become 0.3. So based on this three computation, we calculated the first row of this relation R cross R max min of S. So x1 to z1 will contain the value of 0.6. x1 to z2 contains a 0.5. x1 to z3 contains the value of 0.3. Now we go to compute the second row based on the formula x1 to the z1. Same formula we are going to use it for the x2 to z1. So we have to compare x2 to y1 0.2. From y1 to z1 1, the value will be 0.2. x2 to y2 0.9. y2 to z1 is 0.8. Minimum value from this two is 0.8. Comparing 0.2 with 0.8, the value will become as 0.8. Take the next value x2 to the z2, comparing 0.2 with 0.5 and 0.9 with 0.4. Minimum value from the 0.2, 0.5, the value will be 0.2. Minimum value from the 0.9 to 0.4, the value will be 0.4. So maximum value from this two is 0.4. Take the value x2 and compare with the z3. 0.2 with 0.3, the value will be 0.2. 0.9 with 0.7, the value will be 0.7. So comparing the 0.2 with 0.7, the value will become as 0.7. Now we tabulate the second row inside this relationship. So result will be max min composition of this R with the S. We have the second row 0.8, 0.4 and 0.7. Same way, for the same problem, we can calculate the max product composition also. We will check how to do the max product composition. Formula for the max product composition, we have to multiply this x1 y1 value with the y1 z1 value. Later, you have to compare the x1 y2 value with the y2 z1 value. Choose the maximum value from this two product. So max min composition always represented by this solid circle. So we have to compare the x1 y1, multiply that value with the y1 z1. x1 y2, multiply that value with the y2 z1. choose the maximum value from this two product. First we will start here. 0.6 into 1, the value will be 0.6. 0.3 into 0.8, the value will be 0.24. Maximum value from this 2 is 0.6. Take the x1 is a 2. 0.6 with 0.5, the value will be 0.30. 0.3 with 0.4, 0.12. So the maximum value will be 0.3. So compare the x1 value with the z3, 0.6 into 0.3, comma, 0.3 into 0.7. This will be 0.18, 0.21. So the maximum value will be 0.21. After this 3 computation, the resultant will be like this. So x1 to z1, z2, z3, 0.6, 0.3 and 0.21. Now we go to compute the x2 row. So 0.2 with 1, 0.2, 0.9 into 0.8, 0.72. So the answer will be 0.72. Take the 0.2 with 0.5, compare that value with 0.9 into 0.4. So the value will be 0.1, 0.36, maximum will be 0.36. Take that row again and compare with this column. 0.2 into 0.3, 0.06. 0.9 into 0.7, 0.63. So the maximum value will be 0.63. Now we computed all the values. We got the composition. So max product for this 2 sample will be like this. So we taken the 0.72, 0.36, 0.63 from this slide. From the previous slide we computed 0.6, 0.3, 0.21. We go for a second problem. In the problem there are 3 fuzzy set 1A, fuzzy set 2B, fuzzy set 3C. There are 2 questions under this problem. First one, we have to compute the Cartesian product of the A cross B. And after computing this R, we have to compute the C cross B, that is Cartesian product of the C fuzzy set with the B fuzzy set. Then I call that relation as the S. First we try to solve this A part. So what is a Cartesian product? So it is a choosing the minimum membership value from the A fuzzy set to the B fuzzy set. So we have to compare all the values of that A set with all possible values of the B. First I consider this 1 and compare with the B fuzzy set. So the elements in that A fuzzy set is low, medium, high. B fuzzy set is positive, 0, negative. Compare this 1 with the first value and we have to prefer the minimum. 1 with a 0.9, the value will be 0.9. 1 with 0.4, the value will be 0.4. 1 with 0.9, the value will be 0.9. Take the second value and compare with this remaining values. 0.2, 0.9, the value will be 0.2. 0.2, 0.4, 0.2. 0.2, 0.9, the value will be 0.2 again. Take the 0.5, compare with this 3 values. 0.5, 0.9, 0.5, 0.5, 0.4, 0.4, 0.5, 0.9, the value will be 0.5. So now we calculated the R, that's a Cartesian product of A cross B. We have to try the second B part, that's C cross B. Now we try that. This is the C and this is the B. So the problem is we have to compute the C cross B. So first we have to try the low, medium, high in the row, and the column you have to write positive, 0, negative. Take this value and compare with this remaining value. Choose the minimum. So first element 0.1 compared with the 0.9, the value will be 0.1. 0.1 with 0.4, the value will be 0.1. 0.1 with 0.9, the value will be 0.1. Take the second value and compare with the remaining fuzzy set. So 0.2 with 0.9, the value will be 0.2. 0.2, 0.4, 0.2. 0.2, 0.9, 0.2 again. Take the 0.7, compare with this 0.9, 0.7. 0.7 with 0.4, the minimum value is 0.4. 0.7 comma 0.9, the value will be 0.7. So we got the Cartesian product of C fuzzy set with the B fuzzy set. Now we are going to compute the max-min product for this C set with the R fuzzy relation. Now we try this one. So I taken the 0.1, 0.2, 0.7 and taken all this fuzzy relation value in that matrix format. So for how to compute the first value? Compare this 0.1 with all the values of that R. 0.1 comma 0.9, choose the minimum, that will be 0.1. 0.2 comma 0.2, so the value will be 0.2. 0.7 comma 0.5, the value will be 0.5. Maximum from this 3, the value will be 0.5. Take the x2 and compare with the second one, this one with the second column. So the resultant will be 0.1 comma 0.4, 0.1, 0.2 comma 0.2, the 0.2, 0.7 comma 0.4, the value will be 0.4. Maximum from this 3, the value will be 0.4. Take the third one, x1. I am going to compare this entire form with the third column. So 0.1 comma 0.9, 0.1, 0.2 comma 0.2, 0.2, 0.7 comma 0.5, the value will be 0.5. So the resultant will be like this. Suppose instead of the C max min of this R, we calculate the S. C convert max min of the S. So we go to compare this one with the this value. 0.1 comma 0.1, minimum value is 0.1. 0.2 comma 0.2, value will be 0.2. 0.7 comma 0.7, the value will be 0.7. So maximum from this 3, value will be 0.7. 0.1 with 0.1, the value will be 0.1. 0.2 comma 0.2, the value will be 0.2. 0.7 comma 0.4, the value will be 0.4. The maximum value is 0.4. Take this value again for the column 3. 0.1 comma 0.1, the value will be 0.1. 2, 0.2, 0.2, 0.7 comma 0.7, the minimum value is 0.7. Comparing all these three values, the value will be 0.7. So resultant for the C max min of the S will be like this. This exercise problem, you can try it of your own to experiment what is called the max min, max product and Cartesian product. So for this problem, you have to first compute A cross B. So you have to calculate the Cartesian product of this A cross B. And for the S relation, you have to calculate the Cartesian product of B cross C. For the T, after computing this Cartesian product, you have to take the max min for this 2. After computing this Cartesian product, you can create the max product of this 2 that I consider as the T. The tilde symbol indicate we are dealing with the fuzzy set and fuzzy relations. Thank you, students.